Welcome everyone to the session that is dedicated to Spring Cloud applications that are designed to function across distant geographies. My name is Denis. I've been working with distributed systems, databases, and applications for the last 10 years. And today, I'd like to show you how to build furiously fast multi-region applications using Spring Cloud and a few other components. Why furiously fast? Because we want to build such an application that can handle user requests at low latency no matter where the user lives. Let it be the United States, Germany, France, India, or Australia. So let's move forward and build a multi-region application with Spring Cloud that uses at least 3 regions, one in the United States, another one in Germany, and the last one in Australia. But before we start discussing that simple solution, and you will figure out that that solution is very simple and straightforward if you know what components to use. First, let's figure out why would the one decide to build a multi-region application. What's the purpose? I would define 3 reasons. The first one is high availability. You deploy across multiple regions if you want to tolerate outages, including region-level outages, and those happen relatively frequently. Second one is performance. If you have customers and users who live across various locations, different countries, you want them to have the same experience, which means that the application needs to perform at the same low latency. And the last one is data regulatory requirements. If you shoot for the global deployment, then many countries will require you to put customer data in specific regions. We are going to discuss only the performance aspects of multi-region applications today, but nevertheless, let's quickly walk through those reasons in detail. And we will be using a hypothetical company. The name of the company is Global Crust. The folks used ChatGPT to come up with their marketing motto. They basically blend tradition and innovation in the pizza industry. And they created a simple Spring Cloud application. They deployed it in that famous United States East 1 region in Northern Virginia. Why in that region? Because in the beginning, they're planning to serve the pizza for the folks who live in New York City and Jersey City. But certainly, they have global vision. Overall, they're planning to offer this pizza across the world, if possible. And they deployed this application, and a month later, the application and the service went down for almost 4 hours. What happened? There was no any single bug in the application, and everything was very well crafted from their architecture standpoint, but unfortunately, they became a victim of a region-level outage. Yes, United States East 1 region went down, and in general, if you take a look at different statistics, every 50 days, there is a major outage in one cloud region or another. It doesn't matter whether you use AWS, Azure, or Google Cloud Platform, you might become a victim of a region-level outage. And on average, it takes 4 hours to restore from that major failure. And the folks from the Global Crust learned the lesson, and right now they are running this service across close locations. They still have this application instance running in the United States East region, but also they deployed one instance in Iowa and another one in South Carolina. Okay? And again, we are not discussing the high availability aspects. If you're interested in how to use why would you build and how you build multi-region applications for high availability, check the recording from the previous Spring 1 session that was delivered online. It's available on demand. But right now, let's take this lesson. So right now, the application is running across 3 regions. And the customers who live in New York and New Jersey are happy. They love the pizza, they love the service, they love the product. And also, they started serving this pizza in Chicago and in Miami. So that's how they also can benefit from those multi-region locations in the East Coast. But then the company is thinking, should we open a branch in San Francisco or probably Atlanta and other places? And they say, yeah, probably sometime in the future. But why don't we experiment with other locations? Why don't we start serving this pizza in Europe? How about Berlin? And also, let's go to Sydney. So they started providing this pizza to the folks who live in Berlin and Sydney. But if you take a look at the architecture, they do not deploy the application instances in those locations. And how does it impact the experience? The folks who are ordering the pizza, they're using mobile phones or web UI. So generally, let's say I pull up my phone, I'm going through the menu, I'm probably creating some custom pizza, picking from different ingredients, etc. And the latency for those who live in the United States East Coast, in New York, in New Jersey, the maximum latency would be around 25 milliseconds for the time when you need to put your order, pizza order, in the system. Just because this order needs to be replicated synchronously across 3 regions. And the latency between those 3 regions, Iowa, Virginia, and South Carolina, can be around 25 milliseconds. But how about folks who live in Berlin? You know, they can start complaining about some sluggish user interface if they use the mobile app. Why? Because the laws of physics, the traffic, the requests from the mobile phone of someone who lives in Berlin needs to go under the Atlantic Ocean, the traffic, before it gets to the United States. And what's about the folks who live in Sydney? Oh, come on. They cannot use this application at all because their requests need to travel through the Pacific Ocean, which is a much longer road. And eventually, what the Global Crust company and team decided to do, they eventually deployed multi-region application. They already had that multi-region application in the United States, but they also went to the European data centers and to Australia. So generally, you need to have at least one, you need to have application instance running in all of those locations, and you also need to decide about your database deployment, because if you, let's say, deploy application instances in Frankfurt data center or Sydney data center, but the data still remains in the United States, then all of the requests, the application will, the backend part of your application will be forwarding to the United States, and you will not solve anything. So let's talk about essential components for multi-region applications. In multi-region application, also multi-region applications are usually referred to as distributed applications or global application or geo-distributed applications. And the simplest definition is a multi-region application. As any other application, those apps come with 3 essential components. You need to have your application layer, the backend, and those your micro application instances that are deployed in the location of your choice. Then you should have and you should benefit from the global cloud load balancer. Why? Because imagine that you are deploying your application instances in the United States, Europe, and Sydney, and right now you have how many? At least 3 IP addresses, 3 host names. And your mobile guys and your web front-end developers need to do something with those IP addresses. How will they decide what application instance needs to serve the next user request? And what happens if one IP address becomes unavailable? It's getting very, very, very messy. That's why global load balancers is an ideal solution for you. Every cloud environment comes with a global cloud load balancer. Basically, you're getting one IP address. You can assign one host name to this IP address. You give this IP address to your mobile application developers, and that's it. Then, if your user is sending a request from Berlin, then the load balancer will understand that the traffic is coming from Germany, and the request will be forwarded to your application instance that is running in the Frankfurt data center, not in the United States and not in Sydney. And as for the database, certainly you need to store data somewhere, and ideally you need to think about distributed database, because that's a multi-region application. Some data needs to be available in every location. Some data needs to be available only in one location and not in another. And distributed databases are designed for this type of global applications. So let's build a sample application using Spring Cloud. How many of you have heard about Spring Cloud? How many of you use Spring Cloud? Excellent. Almost everyone. Just in case so that everyone has at least a basic understanding of what that is, I define Spring Cloud as a framework for building distributed applications in the cloud. And the framework comes with many components. For instance, you can use config server so that your microservice instances running in different locations can get the configuration that is relevant for that instance. You can certainly use discovery service that allows your microservices talk to each other directly using their names, not any IP addresses. You can use API gateway if you want, just to process some requests and then to decide which microservice instance is going to handle this request. And there are many other components that you can go and find on the website. For the global crust application, right? Let's build a naive version of this application. Something trivial that will help us to experiment with the latency. Because today we are talking about the latency. We want to build a version of this application that delivers the same low latency across all of those 3 locations: Berlin, United States, and Sydney. So what we are going to use? We are going to have, let's move from right to left. So we are going to have the kitchen microservice. It's a Spring Boot application. So basically, whenever you take your mobile phone or send some REST request, that you are going to add a new pizza order into the system. And then the chef hopefully will start baking your pizza within the next minute or 2. Also, once the order is in the system, you can use the tracker service. This is what we can use from time to time as customers. We want to check the status of our pizza. Is it still waiting for being baked? Is it being delivered, or where is it? What's happening with this pizza? Both microservices are will be registered with the service discovery, also known as Eureka. Why? You can have as many instances of these microservices as you like. And the discovery service will keep track of all of those instances and let those microservices and API gateway communicate to each other by just providing a service name. And next we have the cloud gateway, Spring Cloud Gateway, not the global load balancer, don't confuse it. The cloud gateway basically will be receiving HTTP requests from your web traffic, from your mobile traffic, and then it will decide whether this request needs to go to the tracker service or to the kitchen service. And it also will be registered with the discovery so that the cloud gateway doesn't want to know the IP addresses of your application instances. It basically just wants to provide the name of a microservice, and then the discovery will return a list of available IP addresses and connection endpoints.
Traffic really doesn't flow through service through service discovery.
Yeah, I know. Yeah, it's basically, you're right. On this slide, what I wanted to show initially is that all those my custom microservices and cloud gateway, they use service discovery to find out an IP address, a connection endpoint. But right, like once you, because cloud gateway will be connecting directly to the tracker service and kitchen service. It's basically we as speakers, we had to prepare the slides ahead of time, and then I decided, all right, let's leave it as this. And if anybody asks, I can explain that it's a little bit different write flow, right, or read flow, if you like. And now let's say we already have customers in New York, we have in Berlin, with Sydney. What do we want to do? How do we make this application global and run across multi-regions? It's simple. We just take and deploy this application instances across all of those locations. I have the same configuration: cloud gateway, service discovery, custom microservices in Virginia, in Frankfurt, and in Sydney. It's trivial. It's simple. Just one command probably in your deployment notebook. As for the data, again, the data needs to be available right in that place where your customers are ordering the pizza. If this doesn't happen, let's say you live in Sydney, you want to order margarita pizza, but then you're just spending God knows how many seconds trying to see what are the ingredients, what's the cost, etc. You want the data to be available in Australia, not in the United States. And a global cloud load balancer, I'm not going to demonstrate it today, but that's basically a very useful and handy, straightforward component. It depends on what your favorite cloud environment, let it be AWS, Azure, or Google Cloud Platform. But generally, the whole concept is that your mobile applications and your web front end is going to connect to this component, to the global load balancer that comes with one single IP address, virtual IP address, and then the load balancer will decide, all right, this traffic needs to go to Sydney because the user who is ordering the pizza lives in Sydney. So that's simple. And then that request will be routed to Cloud Gateway, and the Cloud Gateway will send it to Service Discovery, Kitchen Service, etc. Speaking about the databases, right, just one quick slide about with Global Load Balancer and with the Spring Cloud and custom microservices, it's all simple, literally. Whether you're building single region application or multi-region, you just need to deploy multiple instances across several locations and put a global load balancer. When it comes to a database, it's all about trade-offs. You would need to decide what's the best application, what's the best deployment option for your specific application. So we'll review 4, and I will demonstrate you 3. So the first one is, what's the database for today's experiments? We will be using Yugabyte. Why? Because I work for this company, and the company pays me to talk about the database. But on a serious note, this is a distributed database that is designed for this type of applications, for the applications that run across multiple regions or availability zones. If you, as a 1-minute introduction to Yugabyte, what you should remember, it's built on PostgreSQL. Anybody uses Postgres? It's built on PostgreSQL, literally runs on PostgreSQL source code, and you can think about it as of a distributed Postgres. We historically support Cassandra query layer because many folks who love the scalability of NoSQL databases want to have consistency of relational databases. They move to Yugabyte, but they want to keep using Cassandra APIs before they switch to SQL. So basically, it's a query layer and storage layer. Storage layer is what makes Yugabyte different from Postgres. Automatic sharding, distributed transactions, Raft consensus replication. So how is it different? So that you understand how much is it different or close to Postgres. Imagine that's your Postgres server running. It also has query layer, storage layer, that's disk, and Yugabyte uses Postgres query layer. It's basically Postgres source code with some modifications. And those modifications were necessary for the Yugabyte storage layer that is called DuckDB, so that the query engine knows how to execute those requests. All right, going back to the global crust. You remember that before they started providing service in Europe and Australia, they were deploying in this configuration because their primary customer base was in New York and Jersey City. And when you're deploying across multiple regions, don't just deploy, let's say, a multi-region cluster. Decide what's going to be your preferred region. A preferred region in a distributed database is a region that stores the primary copies of your records. And the redundant copies will be stored in other regions. That allows you to minimize the traffic between the regions. So generally, even if you put a node into the cluster, the request will go to the United States East region, the green one. And then from that region, it's going to be synchronously replicated using Raft consensus protocol to the other 2 locations. But then if you're running selects, if you're running some select switch joins, etc., the requests will always go to the United States East by default. That allows you to minimize the traffic between all of those 3 different locations. If you, let's say, deploy application instances in Chicago or Miami, then in such configuration, you can benefit from so-called follower reads, which allows you to read from secondary data centers, from the data centers that store the redundant copy of your data. That also will allow to boost the performance for reads. So let's now take a look how it works in practice. And we are going to use a deployment with preferred region. First, my application, right? The pizza store. What we have their kitchen controller. It's a basic REST controller with several API endpoints. Depending on the API endpoint, we're receiving the request, and we are either inserting an order into the database or we are updating the status. So what's about their tracker microservice? So the same, it's a REST controller, and here is you have several endpoints, and we are going to return the status of an order depending, and also sometimes you can filter using the location. So both these microservices, they register with their kitchen application. They register with their discovery client, with the discovery service that allows to connect to them by name. And next, discovery application. So you can download it using various ways. I just went to Spring Initializer and I downloaded a jar from there. And when you start this application, you need to provide this annotation, enable Eureka server, and after that, you will have your own instance of the discovery service running whenever you need. From the PAM XML file, how does it look like? Discovery server. All you need to have is this dependency, literally. Spring Cloud, Netflix, Eureka server. And the final component of my application is the API gateway. So this one also registers with the discovery service. It's a Spring Boot application, and what it has the following route locator. So I have a route for the kitchen service, and if the kitchen is in the query path, then we are going to forward this request to this microservice. So this microservice is my kitchen microservice. Let's go to the application properties. That's the name that I gave to this microservice. And I'm just providing this name in my gateway configuration. This is LB stands for load balancer. So basically what happens here, once your gateway identifies that this request goes to the kitchen microservice, it sends this request. And this request will be handled by the discovery service. You ask discovery service, give me IP addresses for the kitchen service endpoints. And if there are many, then the gateway is going to load balance requests across those application instances. If there is one, then just one instance will receive this request. And we have a similar comparable configuration for the tracker. Okay? Now, we are talking about several locations. So I'm using Google Cloud, and I have several virtual machines. One is in the United States East, then Europe, that's Frankfurt, and this is Sydney. From the database in pointer, that's my cluster. I'm running a multi-region cluster across Iowa, South Carolina, and North Virginia, and this star means that the cluster in the cluster nodes in the Virginia are the preferred regions, preferred nodes, meaning that the primary copy of the user data will be stored in that location, and the redundant copies will be stored in their other two regions. So here is my application. Let me clean it up. So that's the connection to the VM in the United States. Let me just in case delete all the application records. And first what we are doing, let's start application instances connecting to that cluster. We are connecting, we are starting kitchen tracker. We are going to reboot the discovery service and API gateway. Let's do this for all of their regions. That's in Germany. And this is in Australia. So now, once it's ready, we actually can connect and see, we can connect to the instance of the discovery service. Let me use the IP address for the United States. If you go to there's one and provide this port number, 8761. So here is what you can see. That's the dashboard. It should be familiar to those who use Spring Cloud on a daily basis. These are our two microservices. They are registered. And this is their gateway, my API gateway. They are running. And just to double check that this deployment is ready in other locations, let's check. Let's connect to the discovery service in Frankfurt, in Germany, up and running. And the last one in Australia. All is good. So we are ready. Now let's send the first request. Let's put some order in the system. So that's this request. I'm going to use HTTP tool. That's going to be post request, and I'm connecting to the Spring Cloud gateway that is running on this machine. And this request will go to the kitchen microservice. Let's imagine that someone has ordered pizza in New York. And now let's repeat this request a couple of times, and let's see the latency. So the total latency is around 300 milliseconds. It's just relative latency. I'm running on a low-end virtual machines with 1 or 2 virtual CPUs, so just uses just as a baseline to compare against other regions. As for the database instance, the database latency is around 20 milliseconds. Why? Because this request goes to their database node that is deployed in the United States East Coast, and this virtual machine is also running in their Northern Virginia. But then that node needs to replicate this order to Iowa and to South Carolina. So that's why the latency is around 20 milliseconds. If you're running in a single region configuration, the latency will be much, much lower. But we are talking about multi-region deployments. Now let's compare this to the latency in Germany. Let's say that someone from Berlin decided also to order pizza. Let it be ID number 10, and the location is Berlin. Let's repeat this a couple of times because I want the connection pool to warm up, to open a few connections. You'll see that the total latency is almost 2 times bigger, right, if to compare to the United States. But the primary reason why the bottleneck is the database. If you subtract this number from this one, then you will get the total latency that would be comparable to the one in the United States. So why this is happening? Because the requests needs to go from Berlin to the United States. That's where the database lives, and that's a problem if you want to scale. And Australia would not be that different. In Australia, the situation will be even worse. Let's do someone is buying pizza in Sydney. Again, we are refreshing, opening connection, warming up connection pool. So the total latency is larger, even if to compare to Europe, because the traffic goes through the Pacific Ocean, I hope. And the primary reason is the bottleneck. The database is the bottleneck. The latency between their backend, between the microservice, the kitchen microservice, and the database is almost a half a second. That's the problem. So, and the reads are not different. If you decide to do the read, if, let's say, I want to check the status for this order in New York, it's going to be 5 milliseconds for the United States because the order is stored in this United States East region, and it's a very quick check. But if you do this for Berlin or Australia, it's going to be slower. It's going to be still around 200 milliseconds. This is something that we need to fix. So what we have right now, right, we generally solve the problem from the application standpoint. You have the application instances and you have Spring Cloud components running in all of those distant locations, United States, Europe, and Australia, and they execute really fast, but the problem is the bottleneck is here, the bottleneck is the database. So what are the options? How can we improve the latency for our multi-region application? So you need to think about different database deployment options. Because the multi-region deployment was enough if your primary customer base lives just in the United States. So what else? Another typical solution is replicas, right? Many of us use read replica nodes. Many databases support this. And distributed databases such as Yugabyte DB is not an exception. You can attach read replica to your primary cluster, and read replica will be storing the data that is synchronized and sent asynchronously from your primary location. What else? What if you want to boost read and write performance? Because with read replicas, you will be able to accelerate your read requests, but not writes. Writes still need to go to the United States. Then, another classical solution, you can always deploy multiple standalone database instances in all of those locations, but there is a trade-off. The trade-off is that if you want to synchronize changes between those database instances, it's going to be a synchronous replication. If your application needs to query all of those various database instances, then the application instance needs to keep track of all of the different connection pools, different database endpoints, etc. It can be problematic, and you need to join the data on the application layer. Another approach, the last one, if you want to boost performance for both reads and writes, is to use a geo-partition cluster. This is supported by distributed databases. The trade-off here is as follows. In your tables, you define a special column called geo-partition column. It can have any name, literally, and it can have any value. For instance, for the global crust, we are adding the city column, and if the city if record has, if the value is New York or New Jersey, then this record will be automatically placed by the database and stored in this location in the United States. If, let's say, the city value is Sydney, then the database will automatically place or read the records from Sydney and not from the United States or another location, okay? So how does it work? Let's see. Yeah, that was the last slide. But we are not done yet. So we are not going to touch United States. Let's just use United States as a baseline. So that's our latency, 8 milliseconds. But here is we are going to restart our kitchen and tracker microservice instances by connecting them to the replicas. These replica nodes are running here. You see, that's still my multi-region cluster, and I have replica in Frankfurt and I have replica in Sydney. So I have restarted in Europe and I'm restarting in Sydney. We can use discovery service to see when their microservice instance is up and running. Not yet. This is Europe. Okay. It's boosting. It's booting. We are ready in Europe. And I think soon we will be ready in Australia. So let's move forward with Europe. So right now, if I decide, let's say, to check the status for the order 10 that was added previously for Berlin, yeah, service unavailable. It means that it takes some time, and there should be some defaults that you can change. The service is already available, but Cloud Gateway, the Spring Cloud Gateway has not seen it yet, and that's not its problem. That's my problem. I should have, just updated some configuration property. Yep.
So in one of your slides, you spoke about the global load balance.
Uh-huh.
Where is that installed? That add latency when you have...
No, that one, we do not use it here in this session. You basically go, let's say if you use Google Cloud. So here you can find global load balancer, and you can configure it. It's a special component, cloud load balancing. And Google will give you an IP address, and you will give this IP address to your mobile applications and your web front end. And then when you configure this cloud load balancer, it will be looking at your Spring Cloud gateways. Make sense?
But once you install, you are still going to see the latency, right? Because it's going
No. Because Google comes with many point of presence around the world. Think about this as an entrance to the Google network. So you have a point of presence in Sydney, you have it in Frankfurt, etc. So your request will enter the Google network from the closest location, and usually it's.
What you're demonstrating.
I'm not demonstrating it.
The database latency.
Yeah. It's just because the database in this configuration, the database latency is the worst, and you need to fix it. So here is right now. Let's take a look. We were able to connect through the replica, and right now. The database latency is comparable to the United States, like 5 milliseconds. And the total latency is also around 350 milliseconds. So the same is going to happen for Australia. We have an order in Australia, in Sydney. So why does it take so long to open the first connection? The thing is that the primary nodes of your cluster that are in the United States, they store system metadata, system tables, and when you warming up your connection pool, that system metadata needs to be transferred to the read replica. And unfortunately, it takes time. So I know that Yugabyte DB team has been working on some optimizations so that you can cache this information at their replica node level, and not to do this for every new connection, but that still works. Nevertheless, once your connection pool is warmed up, you can compare the latency and see that the latency is also around 5 milliseconds. So one achievement, right? You've managed to achieve the same comparable read latency for all of your locations. Trade-offs, read replicas don't usually have the latest data. There might be some data gap because the changes needs to be transferred from the primary cluster to the replica nodes, but it's all transactional. There will be no any data inconsistencies. And now let's demonstrate the geo-partition cluster for the scenarios when you want to achieve both read and write latency, comparable read and write latency across several regions. For that, let me restart my custom microservices. I'm not going to restart Discovery Server and a Cloud Gateway, but I'm going to connect to the geo-partitioned cluster. So this one is going to connect to the Yugabyte DB node in the United States, and I will show you that cluster. Let me first reboot those services. This one is in Frankfurt, and the last one is in Sydney. Oops, no. Let me cancel this one. Cancelled. I want to connect to the geo cluster, right, in Sydney. Cool. So that cluster, that's the second cluster of Yugabyte DB that I'm running. So what I have here, I have 3 database nodes in Sydney region, then 3 in Frankfurt, and in the remaining 3 in Northern Virginia. That's the cluster that I have, and the data will be distributed based on the city value. If the city column is equal to Berlin, then the data will be stored on these nodes in Frankfurt, not in the United States. And that will help me to achieve low latency like across all of those locations. So now let's quickly check that those microservice instances are up and running. We are checking with the discovery service. All is good in the United States, all is good in Europe, and all is good in Australia. Now checking the latency. Again, the baseline for us will be the United States. That's a new cluster. Let me just in case remove all the previous orders that I might have added into the database. And now again, we are using our gateway. We are adding order number 1 for New York. Let's repeat this a couple of times, making sure that there is no any latency for the database connection. So the latency is around 8 milliseconds. Why 8 and not 20? If to compare to the previous cluster, because right now I'm running within a single region in the United States. If you want to do this across multiple regions, the latency will be a little bit higher, as in the previous discussion. But that's what we have right now, 8 milliseconds, that's our baseline. Let's now do this for Germany. We are adding order number 10. For Berlin. And let's do the same for Australia. So the reason why it takes to send the first request is the same, because even though you have a single geo-partition cluster and every location needs to store the local data, there is still that system metadata, system tables, that are by default located in the United States. And when you open your first connection, and if your connection pool is not warmed up, that information needs to be transferred from the United States. So and let's add this order to Sydney. All right, checking this one more time, order number 11, order number 12, and wonderful, right? Right now we have the same latency for writes. Doesn't matter whether you live in New York or in Berlin, you will have the same experience, the same latency. So you have the same components, you have some geo-partition database deployment. How about Australia? The connection pool was warmed up. We are checking the latency in Australia, someone order speeds in Sydney. And it's the same, it's even better, like 1 millisecond faster. All right, so this is what you can achieve with the geo-partition deployment. Several options for you. When it comes to the Spring Cloud deployments, it's all easy. You just pick from your required Spring Cloud components. For this application, we used Spring Discovery Server and Cloud Gateway, 2 essential components. Then don't forget about Global Load Balancer. I was not demonstrating it today, but we can discuss it offline. And the database, you have several options, right? If you need to accelerate just reads, you can use read replicas. If you want to accelerate both reads and writes, it depends on how far your clients are from each other. You might be enough to deploy a single cluster with a preferred region, or you might need to deploy a geo-partition cluster. Good. Questions? Yeah, we are done. We have 1 minute.
Does this have the intelligence if you're in if you specify New York, will it write back to New York?
Yeah. Let's do that. That's a wonderful question. Let's say that I want to see the status. Let's do the get, right? As an example. I can do the write, I can do the read. Just let's do the get. I want to get this order number 1, which is in New York. And the database will see that, yes, I need this data, but this data lives in the United States. Why is it slow right now? Because that's a different microservice and it still needs to refresh the metadata. So I will run this request one more time. But generally you can do this. And you can even for instance, if you want to do a request like this, let's say that you just don't know like what's the location of this order number 10, you remove this location, you send this request to the database. That's post request. Let's do read number 10 and location, no location. It takes more time. It took me 1 second at the database level because the database understood, all right, I cannot pin this request to a specific geography. That's why I am sending this request to all of the cluster nodes. What's good for us, for the application developers, you don't need to manage all of those. Like your application instance that is in the United States has just one IP address. And yeah, and let me show you here from there, let's say from Sydney, I can request a record an order that is in New York. So you can also do this. It's just going to be high latency.
For reporting purposes, let's say I built this,
Mm-hmm.
all my reporting is done. Can I then optimize that to replicate everything back to US just for reporting? Or?
Yeah, your configuration can be as advanced as you like. So right now, for instance, for the reporting, if I'm using this geo-partition cluster, right? For instance, this example returns me. I think that I can even get this orders, all the orders, right? It will request all the data from all of the locations. If you don't like the latency, then yeah, you can actually run read replicas alongside in the United States, or you can. I don't know, you can do this multi-node cluster deployments. It's all up to you. It depends on what's your SLA, like what's your SLA for this report. But with this geo-partition cluster, your reporting tool will be as simple as possible. You will have just one or a few database connection endpoints, and then the database will decide where to route this request, where to pick this data from. No. So from the database standpoint, let me show you application properties file for kitchen. That's the database. I'm passing the database address. I'm using Postgres JDBC driver.
What you're using?
That's default. Yeah.
But in a real geolocation, a geo-distributed environment.
Yeah, like I have it here in my as my environment variable. So for instance, that's the instance. That's the United States instance. It connects to the node, database node.
That environment is always different.
Yeah. Let me show you. For instance, yeah, this is Europe.
So could you use Eureka to provide, like, so that in the app config you just say connect to my database, and then in Eureka it says, oh, here in Berlin that's.
That sounds like a reasonable feature request for Yugabyte DB or like.
I know.
Yeah, it's not. Yep. Not right now.
Yeah.
Yeah.
That's what. I just didn't know.
What I used in the past, I did not use this in this demo, but I used Spring Cloud config server. In the config server, for instance, yeah, it's like basically, yeah, that's.
Different profiles.
Yeah, different profiles. Yeah.
The developers like to just say, I don't want to manage all that. The database. I want to. It doesn't matter what cloud I go to. I want to manage the database.
Yeah. Thanks a lot.